Okay, good evening, everyone. Thanks very much for inviting me to come along this evening. Thanks very much to Phil for his really good overview and giving us an idea about some of the challenges that are facing the sheep industry, particularly with respect to these iceberg diseases. So, as he's mentioned, as Phil mentioned, and Damien as well, the next part of this webinar is to have a look at some in-depth some diseases of iceberg diseases, and this one is about Johne's disease. Some of you will know quite a bit about Johne's disease, but some may not. So I just want to just generally go through a brief description of what Johne's disease is. Some of the diagnostic tests that are out there and available, what they can and what they cannot show and tell you about your flock or your individual sheep, and some management strategies for managing Johne's disease from preventing it from coming into your flock, but also if you do end up having it in your flock, how to maintain it and keep it under control. And as part of that management strategy, I'd like to suggest that you can look at vaccination as well. So I'll have a quick look at how vaccination can help control this disease in flocks. So Johne's disease, it's an infectious intestinal disease caused by Mycobacterium avium subspecies paratuberculosis, MAP for short. So I'll be calling it MAP from now on this evening. It really is a wasting disease. So the problem is, because it's an intestinal disease, it means that the food, the nutrients that the sheep are getting just are not being absorbed through the gut, and so these animals really do struggle and suffer with clinical disease. It is mostly in ruminants, so mostly cattle, sheep, goats, deer, but also in other ruminants around the world. It is very much a worldwide problem. There's no doubt about that. Young animals are the most susceptible, and they will pick it up mostly through a fecal oral route or through colostrum from their mother's milk. There's also two other ways of transmission, which are in utero and via the semen. The thing about this particular disease is it is amazingly prolonged. So you can get, a lamb can get the infection very early on and then not show any clinical signs whatsoever, but would still be able to shed that bacteria into the fields or into grazing or into the barns, and that can be transmitted to other sheep and other animals on farm. Which is a big problem, and this incubation period can carry on for 3-4 years. And as I said, many animals also never get the disease, never show clinical disease anyway. They're infected, but they never show disease through their entire life. But as I say, are sort of like silent keepers of the disease, and will just be able to spread it around the farm if it's not controlled. So just to let you have a little look at a visual here of this triangle. This is just to try and show you a little bit about why we think Johne's disease is an iceberg disease. And if you look at the top of the triangle, advanced clinical disease or clinical disease where you're actually seeing symptoms of Johne's disease, that wasting away of the body, and also occasionally they'll get diarrhea as well. If you get one or two of those diseases, if you look down into the silent infections where there's no clinical signs, you could get up to 15 to 25 sheep within your flock that would be silently infected from just one or two that you might see as clinical disease. This is one of two graphs I'd like to show you tonight. This was a really nice way of illustrating what's going on in this disease. If you look at the horizontal axis along the bottom there, that's just time from the time of infection, and up the vertical axis there is the level of response of a variety of different things. So as you can see, and I have my mouse here, is during this sort of subclinical phase, so this is when you're not showing any symptoms, the bacteria will continue to replicate, and the disease will progress until a point where after this sort of clinical phase, when you start seeing symptoms, there's a clear antibody response. Early on, that antibody response is very low. Also, fecal shedding is very intermittent, but can get more frequent in the later stages of disease. Now, these two indicators are really good for identifying the disease through diagnostic testing. So the antibody test, the ELISA test, can be you can use milk or blood samples for that, and it will show whether there's an antibody response to Johne's disease. Now, this in some cases is not so specific and sometimes not so sensitive, but it also shows from this graph that really it's a way of confirming really the disease that you have in that particular animal, rather than something that you can use from a management point of view at an early stage. The same thing goes for fecal shedding. The shedding of the bacteria takes place all the way through, but much more so at near the end of the disease, when the sheep are showing really strong clinical signs. So one of the ways in which we can try to manage this disease is to try and see it or find it early on in infection, before you see any symptoms at all, before those animals begin to shed the bacteria and spread it to other neighboring sheep. So one of those little markers is this thing called interferon gamma. It's an immune response, and as you can see from this red line, it goes up really quickly at a very early stage of disease. And so this is one area that a lot of people have been working on to try and find a way of early detection of this disease in a way so that we can use it to manage the disease more effectively. So this is the new test that's being developed at the moment, and it's going through some field trials at the moment. It's an ELISA, so it can take up to around about 80 or so samples simultaneously. This is the antibody ELISA test for milk and blood, and again, it's a plate-based assay. The yellow indicates a positive, the white indicates a negative result. This is our gold standard, believe it or not. This is us actually growing the bacteria from a sample, either a fecal sample or a milk sample, on a nutrient substrate, so in the lab. So if you get a definite growth of the bacteria, you know that that particular sheep has got the infection. However, this does take between 16 to 20 weeks to grow, so it can take a very, very long time for us to give you a result from this particular method of diagnostics. So, and this is the last particular test that we use. As a molecular test, so it's a PCR test, one that is very similar to those used for the COVID diagnostics at the moment, and it picks up the DNA, in this case, the DNA of the bacteria. And so you can use this in fecal and milk samples as well. As you can see from all those tests, they show very different things, and the way in which they are interpreted can be very different. So there is actually no single test that will reliably detect all stages of the disease, including the subclinical carriers. And a negative test doesn't necessarily mean no infection. It may just be a false negative result. So we'll move on to some of the management strategies and why these have proved to be quite difficult over the years. And one of the reasons for that is that MAP is really incredibly resilient in the environment. This picture over here to the right kind of gives you an idea about how complex the cell wall of the bacteria is. It is very thick as well. This is just, the lower picture is a picture of the bacteria in scanner electron microscope. So when the MAP gets spread onto soil, say grazing or paddocks, you can see that it can survive there for quite a long time water, slurry, and soil. It can reside there and reinfect animals up to 9, 11, or 47 months. The soil very much depends on the soil type. So low pH and boggy peaty soils as well, really good for keeping MAP alive. It's also very resistant due to that really thick cell wall to pasteurization, chlorination, freezing, and many of the antibiotics as well. So a tough nut to crack. So we'll just run now through some of the risk factors that we see, and by identifying these, we can hope to put together a management plan to try and manage the disease. So the first one is really biosecurity, and this is all really about trying to keep the disease out of your farm. However, this is not always possible. Although many farmers like to try and keep a closed flock, that won't necessarily include rams. But if it is the case that you do need to have some replacers after some time, some breeding ewes, then it is really, we think it's a really good idea to try and find a source of those sheep from a farm that has been clear of this disease for at least 3 to 5 years. Where larger numbers of replacements are required, try to buy from a single flock and have every animal tested, preferably before arrival. The other thing that we've seen work really well on farms is screening the occasional cull ewe or poor yielders that have just popped up in the flock, just to get them screened to see what diseases they might have. This includes all sorts of different diseases, but it's a really good way of getting an early warning of maybe that Johne's disease has entered the flock. Worth doing every year or so. In terms of management, we find that in the farms that we work with, the test and cull, as we've mentioned before, is a really effective way, culling out clinical cases, but also removing the infected offspring of those particular animals as well. Keeping hygiene levels high is always a good idea for all sorts of disease control management systems, the lambing pens, of course, as well as where you rear your lambs. And the other thing is that although we know that pooling colostrum is a really good idea, especially when you have a lot of orphan lambs, if there is Johne's on the farm, then that milk can become contaminated from just 2 or 3 sheep might have that, and it might just be in the milk and or the colostrum, and by pooling all that together, then you can contaminate the milk that you're going to be then going on to feed otherwise quite healthy lambs. So trying to avoid the use of pool colostrum we find is a useful idea. The environment is the next one. So looking at the farm as a whole, trying to fence off stagnant areas of water or slow moving water courses is a useful way of reducing the chance of your flock getting the Johne's disease from bacteria in the soil and in the water. It also prevents other diseases from coming on farm, like liver fluke, for instance, and because it also resides in snails. Cleaning out the water troughs regularly is another good idea. In terms of pasture management, we suggest that actually composting your slurry or manure is a really good idea before you put it out onto fields, because the heat within that composting process does reduce the number of bacteria in the manure or slurry. And although it won't eradicate it altogether, it will certainly reduce the load if there's a lot of MAP in the slurry or manure. Try to avoid co-grazing as well. We know for certain that the bacteria that infects the sheep, the MAP that infects the sheep, also can infect cattle as well. So try to avoid co-grazing or sequential grazing if that is at all possible. There are also wildlife reservoirs for this particular disease. MAP can be carried in rabbits and deer and many other wildlife species. It is particularly bad for deer. They're very sensitive to the infection, but for rabbits, they just carry it, sort of silent carriers, and they can spread the disease between pastures as well as farms. So this is the second of my two graphs that I wanted to show you tonight, and this one really, I think, really clearly illustrates the use of putting in a Johne's control program. And again, the bottom axis there, the horizontal one, is years after infection. So if we think of infection just starting off down here at year 0, and then going up to year 30, and the vertical axis here is a percentage of flock infected. So very often at the very beginning, when perhaps MAP is first introduced into the farm, you get very little idea that it's there unless you're able to use an early warning diagnostic test, which, as I say, we're still trying to get. However, it may well be that it rises up to around about this blue line, 10%, and at that point you will certainly realize that something is awry. You'll be seeing clinical cases at this point in your sheep flock, and we know that if no management strategy is put into place, no test and cull, that disease will just progress through the flock and keep going, and really have a major effect on welfare, but obviously productivity as well. If you introduce a test and cull system, so testing and then culling out those individual sheep that have got a test positive and the lambs that they produce, then you can see that you can get this blue line, which does reduce the incidence of disease, but it takes a really long time and never really gets it down to really low levels, lower than say 5%. Introducing management strategies, some of which we've just been talking about. If you introduce that, again, you get a good reduction, but again, it takes a long time, but it does go down to lower levels. One of the nice things, though, is combining these two things together, and you find that you actually get quite a quick reduction. I say quick, it's still going to take maybe 6-7 years before you get the incidence right down to 0. So it still takes a little bit of time, but certainly it is definitely a way of getting this disease under control. The other option is the vaccination. There is a vaccine available for Johne's disease called Good Air, and it can be used, and it does prevent clinical disease and can reduce shedding, but does not eliminate the shedding of the bacteria completely, and it doesn't stop infection. So sheep can still be infected, but it just prevents the symptoms from coming up. And it can reduce, as I say, shedding. It's affordable and it's a single shot, so it doesn't need a prime boost like the new COVID vaccines that are coming online. It's a single shot, and that is for life. So as saying, it doesn't prevent infection, but it certainly can reduce it a bit and reduces the symptoms. But it does also mean that you cannot use the antibody tests for Johne's disease because they will become positive with this particular vaccine. So you cannot tell the difference between the vaccinated and the naturally infected animals using these diagnostic tests. The other thing is we say that it's best not to use in cattle because the bovine TB bacteria is very, very similar to this MAP, and so by vaccinating a cow, then the bovine TB test might come up as a false positive, and that's not recommended. So we don't obviously recommend it for cattle. So if you're interested in vaccinating your flock as it has to be part of a management control strategy, then please be in touch with us or your vet or all of us all together, because we usually work together as a team. So just to give you a little overview of what we're planning to do and what we have been doing in Morden on this particular disease, we've been trying to refine and improve this diagnostic test. As I mentioned, we're trying to get one that is so you can detect the disease at a really early stage. and that would be a really good control tool to use. And at the moment, we're evaluating that in field trials in cattle at the moment, but we're expecting it and hoping it will also work just as well in sheep. The vaccines, we are looking to improve this vaccine, the Good Air vaccine. We're trying to improve it by constructing new potential vaccine strains, and we have got some at the moment in the lab, and they've just recently gone through a mouse model trial and show some interesting and useful results there. So we're hoping to go into the host species, either sheep or goats, certainly to start with, to see how well these vaccine strains work, and they would be able to be used, and you would be able to differentiate between naturally infected and vaccinated sheep, as well as use it hopefully in cattle, as it would be easily not interfere with the bovine TB test. The other thing is we're looking at multi-infection studies. So this is because we know that when we get sheep off farms, that they often have other infections. In fact, it's a well-known thing that mastitis is increased when you have Johne's disease in particular sheep, as well as interesting enough OPA, which we're about to hear about, and also intestinal worms. So we know that these sheep can often have multiple infections, and so that might have an effect on how we treat and prevent these diseases in a more holistic way, rather than just looking at individual diseases. So I thank you for listening. I'm really happy to take any questions at the end of this section of the webinar.